Welcome, curious minds, to the deep dive. Today, well, we're diving into something huge, a question so fundamental, it kind of makes even the experts take a step back.
Yeah, we're talking about the nature of reality.
Exactly. It sounds super intimidating, doesn't it? Like, maybe just for philosophers locked away somewhere.
Right.
But our mission here is to, cut through some of that complexity, give you a shortcut maybe to getting a real handle on this massive subject.
And we've got some amazing source material for this one. It's mainly built around this really fascinating dialogue between a top theoretical physicist and a very distinguished Buddhist scholar.
Yeah, they had this recent discussion on YouTube, and we're pulling from that, plus, their other writings and ideas.
He brings such different viewpoints.
Totally. So think of us as your guides. We're going to unpack these diverse perspectives on what reality even is. We'll look at where they agree, which is interesting in itself.
And where they really diverge. Some really thought-provoking stuff.
Yeah, the goal is to leave you with some genuine aha moments. Things to chew on long after we're done. So, okay, let's jump in. This dialogue. Where did the physicist even start with something as big as reality?
Well, he kicked things off with a bit of humility, actually.
Yeah.
So that talking about the nature of reality can feel presumptuous.
Presumptuous. Why?
Because science, really advances based on what it doesn't know.
For sure.
It's always about pushing into the unknown, right?
Yeah.
Not just confirming what we already have down.
Okay, that makes sense. Physicists aren't just like redoing calculations for apples falling. They're tackling the Big Bangs, quantum computer.
Exactly. But here's where he makes a really key point, maybe a surprising one given all that unknown.
Yeah.
He says reality seems to come to us in layers, not just one single thing.
Layers. Okay, like how?
Well, think about, say, the chair you're sitting on. You can talk about it as, fabric, wood, it's a design.
Or you could talk about it as just atoms, particles, forces.
Right. And both descriptions are totally valid. They're compatible. One doesn't cancel the other out.
I like the iPhone example he uses too. You can talk apps, tapping screens for maps. Or you can talk about the electronics, the circuits, the silicon.
Or go even deeper to the fundamental particles making up that silica.
And the crucial thing, he says, is these layers have to mesh. They have to be compatible. You don't assume there's a tiny person called Siri inside just because you don't get the electronics layer.
Precisely. Most of us get the app layer. Physicists get the fundamental particle layer.
Yeah.
Maybe we don't get the middle bit, the electronics.
Yep, I definitely don't.
But we don't worry about little Siri being in there. And the universe, he argues, is kind of like that. There's this temptation to say either we get everything or we get nothing.
Right.
But the more courageous path, the scientific one, is figuring out where that line is. What do we understand and what don't we?
Okay, so with that scientific humility and this idea of layers,
Yeah.
what's this surprising claim the physicist makes about what is known, the controversial bit?
Right, so he makes this pretty dramatic claim. Might sound almost wild at first. He says the laws of physics underlying our everyday lives are completely known.
Whoa, completely no. What does that even mean? Not like everything about the universe?
No, definitely not. Not the ultimate bottom layer, the nature of space-time itself, maybe, and not the complex emergent stuff way above like biology or sociology or politics.
Or sideways, like dark matter.
Exactly. Not that stuff. It's about the core ingredients and rules governing us and the world we directly interact with. Your coffee brewing, you walking, the sun shining.
Okay, so what is known then? What are these core bits?
He's talking about what's sometimes called the core theory. We know the particles were made of protons, neutrons, electrons. We know the fundamental forces acting between them, electromagnetism, gravity, the strong and weak nuclear forces.
And finding the Higgs boson back in 2012 was a big piece of that puzzle, right?
A huge confirmation, yeah.
Yeah.
It sort of completed that picture, the standard model. And it's not just that we found these things. Quantum field theory, which is this incredibly powerful framework, it basically guarantees that if some particle or force interacts with us noticeably, we should be able to detect it or even create it by smashing other particles together really hard.
Like how they found the Higgs. They made it, then saw what it turned into.
Exactly. So again, this doesn't mean we understand dark energy or what happened before the Big Bang, but for the stuff making up you, your chair, your coffee, the fundamental physics part, the physicist argues, yeah, that's basically settled.
Okay. If you accept that, this core theory, well, the implications sound pretty huge.
They really are.
Yeah.
First off, it suggests things like bending spoons with your mind. That's out.
Because
all the forces and particles are known. There's just no slot, no room in the theory for some undiscovered mental force that could push matter around like that. No mechanism for telekinesis.
Wow. Okay. That's definitely going against the grain for some folks. And this leads to another point he mentions where people often get off the bus.
Yeah, the implication for life after death.
Right. How does the core theory speak to that?
Well, the argument is we know what we're made of, these particles. And all the stuff that makes you, your memories, your personality, your consciousness, it seems incredibly tied to the specific physical arrangement of your brain and body.
Okay.
So when that physical structure breaks down, when the body dies, there's just no known physical law or mechanism that would allow that specific pattern of information that you to somehow continue existing independently.
The atoms are still there, but the arrangement, the information, it's gone.
It dissipates, exactly. That's the argument based on the core theory.
Now, that sounds potentially, well, pretty bleak to some people.
It can, yeah. But the physicist actually frames it quite differently. He finds it liberating.
Liberating? How so?
He emphasizes, look, this life isn't a dress rehearsal. We get a finite number of heartbeats, something like 3 billion maybe, for humans these days.
Wow, 3 billion. Doesn't sound like much when you put it like that.
Right. So every single one counts. This finite reality, it's not depressing, it's a challenge. It focuses the mind, makes you realize how precious this single shot is.
Making most of it.
Exactly. And crucially, he points out, just because we know the underlying physical laws doesn't mean we're just robots. We're macroscopic beings. We still have feelings, thoughts, choices.
The core theory describes atoms, not necessarily how humans live or love or make decisions.
Precisely. There's emergence, complexity. Knowing the physics doesn't negate those higher levels, which actually leads us nicely into the other perspective.
Yeah, that's a perfect transition. I love that quote from the poet Muriel Rukeyser. The universe is made of stories, not of atoms. And the physicist himself kind of echoes that, saying we gain insight by telling the story of the universe in different ways.
It really sets the stage for the Buddhist scholar's view, which leads heavily into this idea of stories or narratives.
How so? What's the core idea there?
Well, the Buddhist perspective really emphasizes that we humans are fundamentally storytellers. It's maybe what makes us unique, this ability to grasp and share meaningful information through narrative.
Okay.
And here's the critical bit. All stories, even scientific ones, start with assumptions, axioms, things you take as given that aren't proven within the story itself.
Right. So the scholar looked at the physicist's view, the core theory, and identified some underlying assumptions.
Exactly. He picked out 3 big ones he saw. Determinism, the idea that the future just unfolds mechanically from the present. Realism, that there's a real world out there completely independent of us observing it. Yeah. And physicalism, that everything that exists is, well, physical stuff.
And he wasn't saying those are necessarily wrong, but
that they represent one story. A powerful one? Sure. But not necessarily the only possible story about reality. What happens if you question those starting points?
Okay, so if you do question them, what other kinds of stories about reality pop up?
Oh, all sorts of fascinating ones, often proposed by other really heavyweight scientists and philosophers. For instance, you've got people like Roger Penrose, echoing Plato and Pythagoras, suggesting that maybe pure mathematics is the fundamental reality.
Whoa, like the universe is math, not just described by it.
Kind of, yeah.
Right.
As if mathematicians aren't inventing things, they're discovering parts of this underlying mathematical structure.
That's mind-bending. Okay, what else?
Then there's another line of thought from physicists like Max Planck, Einstein, James. They floated the idea that maybe mind is primary.
Mind before matter?
Sort of. Planck famously said something like, mind is the matrix of all matter. Jeans suggested the universe looks more like a giant thought than a great machine.
A giant thought.
And more recently, cosmologists like Andre Linde have argued that, hey, maybe our current physics is incomplete because it totally leaves out consciousness. What if consciousness isn't just a byproduct, but has its own fundamental place, its own degrees of freedom? Yeah. Maybe it's even more real than matter.
That's a direct challenge to the physicist's core theory is complete for everyday life idea, isn't it?
Absolutely. It suggests there might be something fundamental missing from that picture. And these are just a couple of examples.
Yeah.
There's also talk about information being fundamental or biology, given the fine-tuning of the universe. Lots of different stories, even within science.
So even among physicists, there isn't one single agreed-upon story about the ultimate nature of reality.
Not at all. And what's really striking, despite all these different takes, is this undercurrent of humility you find. Top scientists, Freeman Dyson, Sean Carroll himself, Marcelo Gleiser, They openly acknowledge how much we don't know. Gleiser said something like, "We are essentially blind to what exists at the very core of physical reality."
Blind. That really connects with that famous Buddhist parable, doesn't it? The blind man and the elephant.
It's a perfect fit. You remember the story. Different blind men touch different parts of an elephant.
Yeah, one feels the trunk, thinks it's a snake. One feels the leg, thinks it's a tree trunk. One feels the tail, thinks it's a rope.
Exactly. And each one is absolutely convinced their description is the whole truth. They end up arguing, maybe even fighting, because their partial experiences seem totally incompatible.
And the scholars saying that's kind of like scientists, or maybe different fields, each grabbing onto their piece of reality's elephant.
Precisely. Each perspective might be valid for the part it touches, but it's not the whole picture. And trying to claim it is the whole picture leads to conflict or just missing the bigger reality.
So from this Buddhist viewpoint, looking at modern science, does he see specific areas where it's maybe being a bit like one of those blind men? Does it have blind spots?
He argues it does, yes. Two main ones he highlights. First, a kind of blindness, perhaps, to the insights from ancient Asian civilizations.
Like from India, China, Tibet.
Yeah, over thousands of years, these traditions developed really deep inquiries into the nature of reality and mind. And he suggests Western science often just overlooks this vast body of thought, maybe assuming nothing important could have been figured out before its own methods arose.
A kind of not invented here bias, maybe. A bit Eurocentric.
That's the implication, yeah. And the second major blind spot he points to.
What's that?
It's the lack of rigorous methods for studying the mind itself from the inside. First-person investigation.
But we have psychology, neuroscience.
Sure, but they mostly study behavior, or they look at brain scans, correlates of mental activity. They don't typically engage in systematic, disciplined, first-person observation of consciousness itself. We study everything else empirically, but not the thing doing the studying.
Okay, I see the distinction. We measure brain waves associated with meditation, but maybe not the subjective experience in a rigorous way.
Right. And this is where he says the Buddhist tradition offers something really valuable. Over 2,500 years, it's developed these incredibly sophisticated techniques for training attention, for developing metacognition, the ability to watch your own mind, basically, to explore consciousness directly.
So it's like an inner science.
In a way, yeah. And he really challenges the easy answer to the mind-body problem, just saying mind is just what the brain does.
Yeah, right.
Or it's just a way of talking about the brain.
Correlation isn't causation or equivalence.
Exactly. Just because brain activity and mental states go together doesn't automatically mean one is the other, or that the mind is only the brain. And he finds it a bit hubristic to declare consciousness definitely ends at death when, scientifically speaking, we don't even really know how it arises in the first place.
A fair point. So if the mind isn't just the brain, what is it from this Buddhist perspective? And crucially, is this just philosophy or is there something testable here?
This is where it gets really interesting. He proposes what he calls an empirical hypothesis, stemming from discoveries made through these deep contemplative practices.
An empirical hypothesis. Okay.
The idea is that through very advanced, sustained practice, it might be possible to sort of penetrate beyond our normal personal conscious and unconscious mind.
Beyond the everyday mind. To where?
To what's described as an underlying continuum of consciousness. Think of it as a sort of fundamental awareness. It's described as purely mental, not tied to a specific human brain, and potentially serving as a kind of repository for memories or information.
Whoa. Okay. He uses an analogy, right? Brain is keyboard.
Yeah, brain is the keyboard or interface.
Yeah.
But this underlying continuum is like the hard drive, holding the deeper information.
A non-physical hard drive, essentially. And you said testable. How on earth would you test that? That sounds pretty out there.
Well, the proposal is quite specific. He suggests that sufficiently advanced contemplatives, trained in very specific ways, might be able to access and recall verifiable details from, say, alleged past lives stored in this continuum.
Verifiable details like names, places, historical facts.
Exactly. Stuff you could actually check against historical records, things the person couldn't possibly have known through normal means. That's the empirical test. It's why he envisions creating maybe a dedicated research facility, a contemplative science center, where scientists and highly trained contemplatives could work together on this long term.
It's ambitious, a collaboration between meditators and physicists, essentially.
Or neuroscientists, historians, yeah. It's a bold proposal for bridging these different ways of knowing.
And it's fascinating to see how the physicist and scholar actually engaged on these points in their dialogue. They really went back and forth on whether mind is just individual brains lighting up or if it's something more cosmic.
Yeah, the physicist had that anti-Copernican argument like, consciousness seems like such a tiny, recent thing in this vast, mostly unthinking universe. How could it be fundamental?
Right. And he brought up Princess Elizabeth's old challenge to Descartes. How does a non-physical mind push around physical stuff? Where does it fit in the physics equations?
And the scholar's response wasn't that mind is some new force, but that, again, correlation isn't equivalence. The mind-body problem isn't solved just by pointing at the brain. And he kept bringing it back to free will versus determinism. That's a huge sticking point.
That whole mind-body thing, it reminds me of a listener question someone sent in about the heart. How does the heart know to beat? Does that need a mind?
Ah, yeah, that's a great illustration. The physicist explained that the heartbeat isn't really knowing in a conscious sense. It's more like an intrinsic property of the heart muscle cells themselves. They have their own rhythm, driven by electrochemical signals.
So it's a lower-level mechanism. It doesn't need instructions from the brain or some central mind for every beat.
Exactly.
Yeah.
It shows how physical explanations work at that fundamental layer, without necessarily invoking consciousness for every biological function. It kind of pushes back on anthropomorphizing everything.
Makes sense. And another listener brought up brain damage. If you damage the brain, the mind changes. Doesn't that strongly suggest the mind is the brain?
Well, the scholar readily agrees. Yes, the correlation is undeniable. Damage the hardware, affect the software. But
Correlation still isn't equivalence.
that's his consistent point. It shows an intimate link, absolutely. But it doesn't, in his view, prove they are one and the same thing or solve the deep mystery of how physical stuff gives rise to subjective experience. And that's also where he brought up that idea of potential Eurocentric bias, again, the tendency to say nobody knows, while perhaps ignoring millennia of introspective inquiry from other traditions.
Okay. What about something completely different, like love? We had a question about how you can love someone with a totally opposite worldview. Where does love fit into physics or these stories?
Yeah, that's a great question because it highlights the different layers. The physicist basically says, look, the reasons you love a specific person, science can't fully reduce that down right now. But the fact that physics underlies everything doesn't mean higher-level experiences like love aren't real or valid.
So the core theory doesn't explain why I love someone, but it doesn't contradict the fact that I do. They're different layers, different stories.
Exactly. And the scholar adds, you ultimately understand love by, well, loving, by the direct experience, not just by analyzing neurons firing.
Which brings us right back to that central point of disagreement, doesn't it? Consciousness after death. The scholar puts out this very specific, testable hypothesis about an underlying continuum, a repository of memories. How did the physicist react to that specific idea?
Well, he remains skeptical, naturally, given the methods and findings of current physics. That idea doesn't fit easily into the core theory. But, and this is important, he showed real openness. He acknowledged the value of seeking wisdom from different traditions, and he agreed that introspection, done rigorously, is a valid way of gathering data, of inquiry.
So, not dismissing it out of hand, even if skeptical.
Exactly. He seemed to see potential for these different approaches, the third-person objective science and the first-person contemplative inquiry, to maybe somehow complement each other down the line, ways we can't quite see yet.
So, thinking about all this whole deep dive, what does it mean for us listening in? It really hammers home that being human is, well, it's amazing, but also really perplexing, right?
Totally. We can ask these unbelievably deep questions about existence, about ourselves, and that mystery, the binding problem. How does subjective experience connect to physical stuff? It's still profoundly mysterious.
It makes you think about those philosophers, the Mysterians, who suggest maybe our human brains just aren't built to fully grasp consciousness, like a dog trying to understand calculus.
It's a humbling thought, isn't it? Maybe some aspects of reality are just beyond our cognitive limits.
But ultimately, I think what this whole exploration shows is just how valuable it is to embrace that we don't know everything, to be comfortable with the uncertainty.
Absolutely. That not knowing isn't a failure, it's the engine. It's what fuels curiosity, what drives us to keep exploring, keep asking questions. It's kind of a celebration of the questions themselves.
So maybe the final thought to leave everyone with is this. If the universe is made of stories, as Rukeyser said, and we are the storytellers.
Then how do you choose to engage with those unknown chapters? The ones still waiting to be written or maybe discovered, both out there in the cosmos and perhaps within yourself?
Something to ponder. We really encourage you to continue your own deep dive. Keep asking questions, stay curious, look beyond the familiar stories. Thanks for joining us on the Deep Dive.